Hello, my name is Kevin, and today we're going to find the contour diagram for C2F2. At this point, what we want to do is find out the number of valence electrons that we have from C2F2. What we must remember is that the valence electrons for carbon are 4 electrons, and the valence electrons for fluorine are 7 electrons. Now, after calculating the number of valence electrons that we are able to use, we find that we have 22 valence electrons, or 11 pairs. A good way to start drawing or finding our way towards drawing the contour diagram will be to first draw the Lewis dot structure of our molecule. To draw the Lewis dot structure of our molecule, we first need to take into account the type of bonds that we're going to have in between atoms. So we can start with a carbon and next to it another carbon. We also have to take into account that we have two F's. So we put an F to the side here and another F, and we start putting in the appropriate amount of bonds. And then let's not forget that we have 11 pairs. So we start with 1, 2, 3. That's 3 pairs. We have a bond here, another bond here, so that's 1, 2, 3, 4, 5. We have 2, 2, and 2. So that's 1, 2, 3, 4, 5, 6, 7, 8 pairs, and we have 10 and 11. Although I've just thought I made a mistake there for a second. So if we count overall, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pairs, which is what we want. Now we move on to making our Vesper theory diagram, which is going to help us further find the contour diagram for C2F2. So for our Vesper diagram, pretty much what we have to do is, in this case, since it's a linear structure, since it's not being pushed off in a bent way by any lone pair that may, cause repulsion to bend the structure, we would have F, C, C, and F. Just pretty much the same in this case as the Lewis dot structure, and this would include the angle, which is 180 degrees because it's linear. We must always make sure that each of the atoms has an octet, so we have 8 pairs for F, 8 pairs for both C's, and 8 pairs for the other F on the other side. Now we start filling in the energy diagram for the central atoms. We start by filling in the appropriate amount of valence electrons. In this case, we're going to do carbon. So we start by putting 1 electron on each part that they belong. So we have 4 valence electrons. And then we promote one of the electrons from the 2s of carbon towards one of the 2p on top. So in the end, we will have 1, 2, 3, and this one's empty. And we call this promotion. Whilst we add energy. And the electrons that are going to hybridize are going to be these. So we take into account that we have taken one from S and one from P. So we have SP, and we have two of them because there's going to be two central carbon atoms. Because of time constraints, I've went ahead and draw the valence electrons for both fluorines. Now let us remember that we have two central carbon atoms, so we need to have two SPs and two p orbitals. Now we can go ahead and fill out the orbitals for one of the SPs and the other one too, doing the same with two p orbitals. Now we must start pairing up bonds. So we're going to have one of the fluorines share an electron with one of the SPs, as well as the other fluorine sharing an electron with the other SP. So we have this pairs, the two pairs right here. Oops, I forgot to add these. So let's redistribute the bonds here. We have this one go right here, this one go right here. Let's not forget the already existing electrons on these empty spaces. Now let's notice that one of the SP it's gonna share its electron with the other SP because they have that triple bond. That triple bond between the carbons. Now we're gonna have the two P's share electrons with each other. So in the end, all of our orbitals are pretty much filled in because they share with one another. The two bonds shared in between the two P's are what we call the pi bonds, and the bonds between the F's and the central carbon atoms are the sigma excuse me, sigma bonds, as well as this one. Let's label the other pi bond. Now we can start drawing our contour diagram for C2F2. What we need to do first is we need to set down our central carbon atoms and their bondings in between them, because of the triple bond. So we have this and this. Let us remember that we have the two shared electrons, and these are going to be our sp bonds. Now we need to insert the bonds in between our fluorines and carbons. So we're going to have bonding pair to the right and a bonding pair to the left. And also we need to write down the part at which our fluorines connect. So put that bond here, this bond here, and these are going to be our sp bonds. With the shared, let me erase that. Our shared electrons in between the C's and the F's. Fluorine here. These are all these three bonds that are in the same line are our sigma bonds. So we put sigma, sigma, and another sigma. Now, let us remember that the bonds in between the two carbons, they're triple bonds. So what we need to do is we need to write down the corresponding to other um, other orbitals. So don't you write these little rabbit ears, if you want to call them, to help us represent our 2p bonds. 2p and 2p. Now, these bonds connect in a very important way. We have these two here correspond one single bond because you can take each little ear as being a quarter of a bond. So when you have four, it's one bond. These bonds go together as well. And then since each red line, each red curve is half, two of them would constitute a complete pi bond. And that's how we build the contour diagram for C2F2. Here at the bottom is a 3D modeled representation of how the bond would look like.